Hi, this is Francis Sideco with TIRIAS Research with another episode of TIRIAS Cast Video. I'm here at Lattice's developer conference this year where they just announced some great new innovations to their small FPGA platform. And I'm here with Deepak Boppana, who's the Senior Director of Marketing for Lattice. He's going to walk us through the Nexus 2 platform that they just announced and some of the demos that they're providing here at the DevCon to show the power of the devices. So Deepak?
Yeah, no, thank you. Thanks. Nexus 2 is our latest small FPGA platform that we just announced at the developer conference. So we have a few demos. So this one actually shows the fast boot up time of Nexus 2 relative to some of the other FPGAs from other vendors, right? So this board has the Certus N2 FPGA from Lattice, the Ardix UltraScale Plus from AMD, and the Cyclone 10 GX from Altera. And all the FPGAs are self-configuring from the single flash device operating at the maximum speed. So let's just turn on each of these FPGAs and check out the boot up time, right? Starting with the Cyclone 10 GX from Altera. So it takes around 359 milliseconds to boot up. Now the Ardix UltraScale Plus from AMD, that's around 260 milliseconds to boot up. And then the Certus N2 FPGA from Lattice, only 17 milliseconds to boot up, right? So
That's amazing.
an order of magnitude faster boot up time
Yeah.
compared with other FPGAs.
So just to explain the demo a little bit, when you're flipping the switch on there, what's actually happening to the devices?
Yeah, so basically they're turning on and basically configuring the bit stream, right? So they're pretty much ready for anything after that, right? Any kind of processing or sensing or security functions. So it's basically how fast can they go from being completely powered down to configure the bit stream and be ready for the next function.
Yeah, so for the embedded applications that these are targeted for, that's extremely important, whether it's just initial startup or if there's some kind of disruption to get it back online right away.
Absolutely.
Aside from order of magnitude faster boot up time, I mean, it's clear to see it's also almost an order of magnitude
Smaller.
smaller,
Yeah.
right? And I think, correct me if I'm wrong, but it seems like a lot of that has to do with the LUT4 architecture that you guys used, both on the boot up time and also enabling the smaller footprint. Can you tell us a little bit about, first of all, what is a LUT4 architecture, and then how that helped you guys achieve some of this?
Yeah, absolutely, right. So, like you rightly mentioned, so LUT4 architecture versus say LUT6, right, is again something that's really optimized for small FPGAs and for low power consumption. In fact, we have a couple of more demos that where we showcase the power consumption, and that directly is a result of that architecture optimization. And like you said, it even helps with the boot up as well, because now you have much smaller bit streams relatively compared to the other FPGAs that have larger bit streams. And we also have faster interfaces, right? So we have XPI interfaces to basically configure much faster, both in terms of the data rate as well as having up to 8 lanes to configure from. So there's a lot of innovative features in these FPGAs.
So just to give a little bit of context, whether it's LUT4, LUT6, LUT8, what exactly is a LUT, and what role does it play in an FPGA device?
Yeah, so LUTs are lookup tables, right? They're basically the basic component or logic block inside the FPGA, right? And you obviously have thousands of those. And that's basically how you implement different functions. I mean, in addition to LUTs, obviously the FPGAs have other aspects as well, like DSP blocks and IO and SerDes lanes. But lookup tables pretty much determine the area that's used and how optimized the area of the FPGA is. So the granularity of the lookup table does matter when it comes to how quickly the devices can configure or how much power they consume.
And is that measured by the 4 or the 6 or the 8?
Yeah, that's the
Okay.
number of inputs for the architectural block. Yes.
Perfect. So this is Francis Sideco with TIRIAS Research. I'm back with Deepak on a second demo that they're showing here at Lattice's DevCon. This one around power efficiency, at certain clock rates. So Deepak, go ahead.
Yeah, thank you. So this one actually showcases the power consumption relative to other FPGAs, right? So again, we have the same board as before, Certus N2 from Lattice, and the other FPGAs from AMD and Altera. And all of these FPGAs are running the same workload at 60 to 70% utilization of the FPGAs, right? So in a lot of these types of applications for small FPGAs, the Fmax or the frequency of operation is typically in the 100 to 300 megahertz range. And that's kind of what we're going to be showing is the impact of Fmax as we change it on the power consumption. And as you can see at 300 megahertz Fmax, Certus N2 FPGA has up to 2 times lower power consumption compared with the other FPGAs, right? And as we lower the Fmax from 300 to say 150 megahertz, you can see the power consumption on a relative basis gets even better, right? Up to 3x lower. And as we go down further to 100 megahertz, it's even up to 4 times lower than other FPGAs, right?
So as you reduce the clock rate, what is it about Nexus 2 that allows it to be basically more efficient as it goes down?
Yeah, it's basically the combination of, again, some of the stuff we talked about earlier, the optimized fabric or lookup table architecture that also kind of translates into lower static power, right, as well as dynamic power as well, right? So on the static power, it's the whole optimization and how small the FPGA is. And the dynamic power is a function of the frequency of operation, right? Like you said, right? So as you reduce the Fmax, the power savings become even more apparent at with the lower dynamic power aspect.
So to what degree do the other areas like memory, for example, affect the performance from this type of demo?
Yeah, good question. I think this is a typical kind of workload, right, with lots of logic fabric being exercised and IO blocks, right? That's one of the core functions of FPGAs is data in, data out. So we're exercising a lot of that as well. And so memory is part of that too, controllers. And yeah, I mean, as we expand the functionality, right, you could put in more DSP functions or more SerDes focused functions, but this is definitely a representative demo.
Yeah, and the only reason why I ask is obviously you've got the logic cells of the processing part of it, and the workloads are the same.
Yep.
So that makes this a very even comparison. I'm just trying to see maybe from a system level standpoint how you guys designed maybe the memory architecture and the interfaces. Does that make a difference as well in your overall results
No,
versus your
it
competitors?
does, right? So it's always a combination of things. And if you take, for example, LPDDR4, right, or low power DDR4 interface is something that we support, and that's contributes as well to achieve that lower power in terms of being able to support that kind of interface, right? And yeah, there's other kind of techniques for power savings as well. And in fact, in one of the next demos, we'll show how we use a combination of boot up time and some of these fabric architecture to even reduce the power more than what you're seeing right now.
Perfect. So low latency, low boot up time, low power.
Yep.
Seems like you're hitting all the spots. So let's look at the last demo.
Sure.
Thank you.
Yep. Thank you.
This is Francis Sideco at Lattice's Developer Conference again with Deepak. So we looked at two of the previous demos around boot up time and power consumption. And that's great being able to do that, but you really need to be able to put that together with a lot of edge AI applications that you guys are trying to support. And it really has to do is when you're in the real world and applications, it's not just pushing buttons when you want it. It's all about duty cycle and when it's on and off. So Deepak, maybe you could show us as you guys bring that all together how the Nexus 2 delivers some of that some of that capability in maybe more real world situations.
Yeah, no, absolutely. And like you touched on, right? So this demo actually showcases kind of both aspects, the low power from the architecture, right? The inherent low power, as well as the fast boot up, and how together they can be used to even further lower power consumption than what we saw in the previous demo, right? So, and this also shows that at a system level, right, in terms of what it could mean for a end system. So we have the same board as before and the same FPGAs, and all these are connected to this signal oscilloscope that's displaying the monitoring rate, right? Which is basically, you can see the number of times the FPGAs are turning on or off per second. And that's what we show here on the monitor, right?
And we
So
say monitoring rate, it's really, a lot of these devices are basically connected to sensors and they're monitoring the output of those sensors at this rate.
that's the typical or a good example of an end application, right, where these FPGAs are right next to the sensors. And depending on the type of application, right, there's some applications like AI PCs, for example, right, that you can probably monitor the output at a lower rate, right? But there are some applications that are more safety critical, like a moving autonomous robot, where you need to monitor the sensor data a lot more frequently, right? So that's what we're trying to demonstrate is what happens or what are the savings in power consumption in those different types of scenarios. So in this example, right, what you see right now at a monitoring rate of 10 times per second, you can see the Certus N2 FPGA has up to 6 times lower power consumption than the other FPGAs. And then we can actually start lowering the monitoring rate and see the difference as well. So at 8 times per second, the power savings are up to 7x, and then 6 times per second, that goes up almost to 10x, and 4 times per second, it's almost 14 to 15 times, right? So that just gives you kind of a range of potential end applications, depending on, again, is it fast monitoring or slow monitoring that's required. And again, those power savings come from the fact that it's again a combination of the low power features and the fact that the Certus N2 FPGA is booting up and to basically turning on and off a lot faster than other FPGAs.
So, because you're able to turn on and off a lot faster, what does that do in terms of? I mean, obviously, these devices are going to consume power most when the duty cycle is on, right?
Yes.
So, what does that allow you guys to do that helps with just the overall system power consumption in a use case like monitoring some kind of sensor?
Yeah, no, that's exactly. It's not just power, right? It's actually even being able to. You can also view it as a performance benefit, right? Because the other FPGAs, after a certain point, like in this case of 10 times per second, if you go back to that scenario, they're just on, right? They're not turning off because again,
Because it takes them too
it
long to
takes them
boot
too
back
long
up.
to boot up. So you
Mhm.
can there are scenarios like that where the other FPGAs just can't hit from a performance standpoint. So it's really, you can look at it from both lenses, right? Performance as well as low power.
So by being able to turn on faster, you're able to actually stay off more,
Exactly,
basically. Okay,
exactly.
perfect. Well, thanks, Deepak. Appreciate it. This is definitely a step up from your previous generation. One thing that probably is worth mentioning, though, this is an evolution or an enhancement, or maybe a better word is an expansion of your Nexus capabilities. So even though obviously this is more capable than the Nexus, what's your, from your standpoint, how do you position, because I'm assuming you guys still want to continue selling the previous generation. How do you help your customers decide, okay, hey, for your application you really should do Nexus versus Nexus 2 or vice versa?
Yeah, no, good question, right? So yeah, definitely, I think it's all about scalability, right? And as we heard in some of the keynotes as well, right, scalability across platforms is something that our customers like to have as well. So think of it as, if you're really kind of happy with the power and performance trade-offs with the Nexus family, then great, right? That's still a relatively new family. We're going to support it for years together, right? Nexus 2 basically continues and enhances some of the performance aspects right? Like some of the things we talked about today in terms of boot up time, or even the Fmax, because some of the small FPGA applications require a higher Fmax, right, which Nexus 2 supports. So it's really the speeds and feeds all go up while still having the focus on low power on a relative basis, as we saw with the other
So
FPGAs.
again, it just expands more options, more tools in your toolbox, and so forth
Exactly, and
for
for
what
our
you're trying to do.
customers, right?
Yeah.
So again, if you take edge computing as an example, there's different types of applications at the edge, and again, both Nexus and Nexus 2 give customers those scalable options.
And you talk about scalability. I assume whether it's Nexus, Nexus 2, or even potentially some of your
Mhm.
other products like Avant and other platforms from that, all of the SDs and toolkits, everything all kind of translates together, and
Absolutely.
you're able to go up and down the tiers.
A great point, right? Yes, all the design tools are the same, right? Radiant, Propel, and even the solution stacks, right? Like Sense AI, for example, right, which is our AI stack. It's pretty much portable and scalable across all those platforms, as are the other rest of our solution stacks as well.
Perfect. Well, maybe just to end, you've done a great job kind of showing it off, and I'm sure a lot of people watching this are like, okay, how do I get one, and when can I get one? Is it generally available now, or what's the availability like?
Yeah, absolutely. I think you can go to our website and you'll see a lot more information on Nexus 2, both from its platform standpoint as well as more details about the latest Certus N2 family. We support it in software, right? Samples are available, boards are available. So, yes, we can get started on your next Nexus 2 design.
Perfect. Thanks, Deepak. Appreciate it.
Thank you.